What up, Calc students? Talking about average value, getting into free response review. You need to do all the average value problems, and then we're going to ask to do 2 free response questions. And then the rest of the free response questions you can do in preparation for the test. And the last part of this lesson is really a transition for us into just understanding an accumulation of something is just equal to the displacement of its antiderivative. The way I try to get us there is through our understanding that the average velocity, knowing that velocity is the rate of change of position, we know the rate of change of position would just be like subtract your positions divided by the time interval in which you're traveling in that position. But then we realize that through our sign analysis of our derivative, that when you subtract your two positions, P of B minus P of A, whatever that happens to be, you actually get the accumulation of the rate of change. This number equals the displacement of position. And we get this idea that if you want an average rate of change of position, you could have actually just accumulated your derivative, your velocity, and divided over your interval. And this is kind of like how we think of averages overall, that if I want to find the average of something, just add up all the things and then divide it by the amount of things. Well, it's kind of what we're doing. We're just like adding up the velocities and we're dividing it over our interval. And then what we realize, this idea can be looked at on any level, which means like P double prime positive, P prime would be increasing. If I did P prime of B minus P prime of A, I get the accumulation of P double prime. If I divide this by B over A, I'm getting the average rate of change of P prime. Well, this is actually the same as adding up all of my accelerations and dividing by my interval. This is the average acceleration. And then if we went up, this might be confusing, but like this is the understanding. And then after kind of getting this understanding, we kind of bypass it. We just go straight to, okay, this is how I do this. If I want my position, and if I know my position's positive, that is going to tell me that its antiderivative, big P, super P, is increasing. And if I need to accumulate my position to get this number, I actually would find the super P at B minus the super P of A. Or if you ever want to accumulate something, you just look at the change of its antiderivative. Now, the place where it makes the most sense to do that is like, here's your derivative, here's your velocity, you get your position. But then you can think of, and it might be confusing, like anything could be a derivative of something else. Like my position is my derivative of the antiderivative of position. Anything is a derivative, which means you can use an antiderivative to accumulate anything. All right. And that's the idea here. Like if you want to find your average position from 0 to 3, well, you could accumulate your position from 0 to 3, add them all up, and divide by the interval. If you have a calculator, you literally type this in. I'm going to do both. We like to graph V. I like to graph V. T cubed minus 3t squared. Cool. There's my position. If I accumulate my position from 0 to 3, if I get 0 again, I'm going to flip. So I should be typing in x of t. Oh, x of t is not something it likes. I'm going to say y. That's something to note. And now that's not friendly. Ooh. This is a problem. Good. This is the accumulation of my position. Just said my position's F. Oh, why don't we change it to P of T? There we go. I like that. P of T is equal to T cubed minus 3t squared. Another reason why we like P of T. Here's the accumulation of my position. It's negative 6.75. And I'm going to divide that by 3. And I get my answer. Cool. Or what you'll see a lot of questions have is in this 1/3 in front. And I get negative 2.25. Cool. Now, this is important. This is another reason why we like to use P of T instead of X of T. Cool. But now, like, if I did not have a calculator, I would need the antiderivative of P. The idea is like P being positive tells me the antiderivative of P is going up. If you want to accumulate P, you can find this number by finding the big P at A and big P at B and subtracting them. Who cares about the C's? So you have to take the antiderivative to get t to the 4th over 4 minus t cubed plus c. You take the antiderivative at 3 and subtract the antiderivative of 0. I get 3 to the 4th over 4 minus 27 plus c. The antiderivative at 0 is c. If I subtract these, I just get that divided by 3, and I bet you that's negative 2.25. Three to the 4th over 4 minus, and this is like, for your spots, you don't have to, there you go. There's your displacement. You shift and highlight it all and then press the division symbol. Divide by 3, negative 2.25. So here's my no calculator approach. I look at the change in the antiderivative to get the accumulation of the original thing. Cool. If I want to find the average velocity from 0 to 2, I can add up all my velocities and divide it over my interval. But I understand that, and if I had a calculator, boom, this is what I would do. I would find my velocity equation, 3t squared minus 6t. Cool. And I would just like plug that in. It's very important that I'm going to plug that into my calculator. Let's see if I could do this. Oh, whoa. Is that right? I don't even have to take the derivative. I don't have to say v of t equals 3t squared minus 6t, because oh, sick. That's so cool. You can just be like, yo, accumulate my derivative. And it does it for you. But it's 0 to 2. Darn it. Okay. Well, even still, I get I get -2. Awesome. Calculator. Awesome. 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 Desmos. Awesome. 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 Your calculator can't do that. It's so sick. Such a math teacher. But we realize average velocity is just the rate of change of position. So an average velocity is actually just an average rate of change of position. So we just find your two positions, subtract them, and divide. Or you could think of, if you have your derivative and you want to accumulate your derivative, you can find the change in P of B minus P of A. Now P prime, P. So you could actually use this and say, oh, my position at time 2 is 8 minus 12, which is -4. My position at 0 is 0. So I have my position at time 2 minus my position at time 0 over 2. And that's the no calculator way to get that answer. Okay. I want the average velocity. Well, I'd love to just accumulate my velocity over my interval and divide it over the change in time. Now look at this. This is something that a lot of people will make mistakes on. Rolling 1 to 3. Great. So I get 2. Maybe you want to write it as 1/2 times integral from 1 to 3 of P prime. You will see this a lot of times on tests, this instead of dividing by. Okay. Now, if I want to find the accumulation of P prime, I could look at how P changes from 1 to 3. Let's say P prime was positive. We don't know what it is. Doesn't matter. P is increasing. This number is how much it increases. I could figure out how much it increases by finding the displacement and subtracting P of 3 from P of 1. Cool. So I have to take the antiderivative, get my position function. T squared minus 6t plus c. I want to find my position at time 3. I want to find my position at time 1. I want to then divide that by 2. 9 minus 18 is -9 plus c. My position at time 1 is -5 plus c. I go from -5 plus c to -9 plus c. That means I decrease 4 total. So that's my accumulation of my derivative, -4. So I got -4 divided by 2. My answer is -2. Then to the question of the day, the average position. Well, I'd love to accumulate my position, add up all my positions, divide by the time. But how do I find this? With a calculator, no big deal. Oh, look at this, actually. We could have figured out what C was. That's important for the future. But even still, -7 to -3 is a displacement of -4. We didn't really need to see. But here's the problem. If I want to accumulate P, figure out this number, I actually think about going up a level. So P prime comes P. P becomes the antiderivative of P. And if I want to figure out this number here, the accumulation of P, I look at the displacement of big P. Okay. Now that means you actually need your exact position function. You need to know that that C is 2. Very important to know that that C is 2. Now I'm going to go ahead and find capital P, which is the antiderivative of P. And I get 1/3 T cubed minus 3T squared plus 2T plus C. And I want big P of 3 minus big P of 1 to get me the accumulation of P from 1 to 3. So I got 27 divided by 3, which is 9, minus 27 plus 6 plus C. And I'll simplify that. Negative 18 plus 6 is negative 12 plus C. And then I got big P of 1, which is 1/3 minus 3 plus 2 plus C. And this is where, like, hey, free response, guys. It's a beautiful thing. If you want to write down your answer, you could literally just say this minus this divided by 2. So I would not include the plus C's. I would kind of know that they would go away. Cool. But let's say it's a multiple choice question. We got to simplify. This is minus 1, 1/3, minus 1. So minus 3/3. So that's minus 2/3. So I got my ending position minus my starting position. So you got to think like negative 2/3 to negative 12. I'm going to decrease, but by how much? 12, 24, 36 thirds, 35, 34 thirds divided by 2 is negative 34 6, or that's 17 thirds. 17 thirds. Okay. That's what I would say is my average position. Now let's see if that works. If I accumulated my position with my position being T squared minus 6T plus 2, and I accumulate that from 1 to 3 of my position, and I divide that by 2, I get what I'm hoping is negative 17 thirds. Ba-bam. Okay. So this is the idea, guys. If you want to accumulate something, you just find the change in the antiderivative. That's the relationship that is so fundamental to calculus that they call it the fundamental theorem of calculus. All right. Average velocity from 0 to 6. Well, it'd be great if I just accumulated my velocity from 0 to 6. Now, what is the accumulation of my velocity from 0 to 6? Well, it's just like the combination of all my displacements. Now, you could say it's your position at time 6 minus your position at time 0. Like, let's see how that's the same. Either you could do like 5 minus 3 plus 1 is 3, and 3 divided by 6 is just a half. Or if you want to, you could say, okay, my position at 0 is 7. This is my accumulation. So like P prime is, you can do the whole thing. P prime is positive from 0 to 3. P prime is negative from 3 to 5. P prime is positive there, which means P is increasing, decreasing, increasing. If you want to accumulate P prime, that's how much we increase. So that's plus 5, that's minus 3, that's plus 1. This is a value that we get. It's like a calculator problem, which means you know P of 0 is 7. You know P of 3 is 7 plus 5, which is 12. You got a question for me?
Yeah, I can ask.
No, let me pause. Okay. Cool. What would be P of 6? Well, P of 0 is 7. P of 3 would be 12. P of 5 is 9. P of 6 is 10. So P of 0 is 7. P of 6 is 10. Oh, 10 minus 7. Oh, yeah, that's just my displacement. That's just 3. 3 divided by 6. Boom, 1/2. So there you go. I mean, it's the same thing here. What's the average velocity? I wish I gave it to you from like 1 to 6. Um, do you have to find the average rate of change of position? I would not find the average rate of change of position. I would just say, oh, this is just the displacement. This is the -2 plus the 6 minus the 3, and I just get 1/6. Um, why did I ask you to do it without a calculator? I guess I did for this one. I wish I had more problems like that, but I guess you'll see it on your free response. Okay. So let's go into free response. For your homework, do one calculator, one no calculator. The rest should be done in preparation for the Unit 7 test. Here we go. This is one of the past free response questions. Given a velocity, it's a calculator question. Should be easy. So long as I know what to do. So I got this. Ooh. Speed of the particle increasing at t equals 5.5. Get a reason for your answer. Well, speed is all about like velocity's relationship to 0. If a velocity at 0 is rest, when your derivative is 0, you're constant, your position is constant. So the question is, are our velocities going further away from 0? Now, here we go. Give a reason for your answer. We need to get into justifications. In one of my classes, I did not get into it in the notes, which we'll have to do on the review day. More. So, your reasoning behind speed increasing or decreasing should be either a comparisons of the signs of V and A. You could talk about your velocity being positive and increasing. You could talk about it being negative and increasing. I don't know. There's lots of ways to answer this. You can talk about your velocity getting closer to 0 or getting further away from 0, but it's easy enough to just go to 5.5. You kind of have to go to x equals 5.5. And you see, this is your velocity, it's negative. You can see your velocity is decreasing. You could literally say, because my velocity is negative and decreasing, my speed is increasing. You could say V of 5.5 is negative, A of 5.5 is negative, speed is increasing. That's probably good. You could say V of 5.5 and A of 5.5 are the same signs. You could say V is negative and decreasing. Whatever you like to remember, just say it. Cool. Average velocity. Cool. Well, I would love to just add up my velocities and divide it over my interval. Well, great thing is they gave me the velocity. I don't have to take any antiderivatives. It's there. It's going to integrate. Like, this is a real free response question from a past year. And I'm going to divide that by 6. You have to write this down, though. You can't just write the answer, 1.949. You have to write this down. 3 decimal places, Rounding is fine. Truncating is fine. I like to truncate. Find the total distance. Ooh, you know what? I could do a full sign analysis to find the total distance if I wanted to. I could see how much my position increases. I could see how much my position decreases from 0 to this point and then from 5 to 6. But guess what? I could also just accumulate all of my positive velocities will give me positive displacements or accumulate my speeds. This is my shortcut. Why don't I just add in an absolute value? How do you absolute value? You come here and you go abs here and do an abs here. If you do the abs on the outside, it won't work, I think. Yeah, so you got to have like positive velocities times positive times from 0 to 6. It likes to go from left to right. I think that makes it positive. So 12.573. It's easy. You could do your derivative analysis, positive until A, it's negative from A to 6. You could know that your position increases and decreases. You could say, well, my accumulation from 0 to A of P prime, I will keep positive and then I will subtract my negative accumulation from A to 6 of P prime or V, and you will get that same value. For example, let's do that just so you can see. And this is what we have to do with a calculator. And you'd have to actually take the antiderivative to find all those displacements. There you go, 12.573. Cool. You could, but why? You have a calculator and use it. Particle changes direction exactly once. Find the position of the particle at that time. A equals that time when we change direction. Now, you probably need to justify this answer. You'd say A equals 5.195. You could say P prime changes signs, or you could say V changes signs. Therefore, your position goes from increasing to decreasing. You don't have to say that. Just say your V changes sign or P prime changes sign. And now you need to find the position at that time. So here's what we need to do. P of A equals, am I giving a P of 0? Or a P of 6? Yeah, P of 0 is 2. Equals my position at time 0 plus however much I displaced from 0 to A. You have to write this down. You also, if using P prime, need to say V of T equals P prime of T and X of T equals P of T. It's just easier to keep track of and to understand, and you need to do it if you're referencing it. I'll be using this again in the future, this P. So that's it. You have to show that, though. Your quizzes, you haven't been, but you will have to. So we got 2 plus this integral. What am I doing? 2 plus the integral, 14.134. So you did your meters per second times seconds over your interval to get your meters. E. Find when the particle is furthest right and justify your answer. Okay. Now, guys, the justification is the important part. I will be strict about justification. If you're doing anything in preparation for your tests, it's obviously redoing a lot of problems, but it's also making sure you understand justifications. Here's what I always say: furthest right, you're finding a max. You'd say a max position occurs at a relative max or an endpoint. So I'm going to say occurs when P prime changes sign from positive to negative, or an endpoint. I'm not going to say that in this situation. Like, I kind of know for a fact uh, that we have a max at A. So, since I know for a fact it's at A, I don't have to really check any candidates. I can say max of P of T is P of A, which equals 14.134. But why do I know it has to be a max? Because P prime is positive from 0 to A, and then P prime is negative from A to 6. That's all you need to write. You don't have to say, since P prime is positive, P is increasing, and you're going right. You don't have to explain much, but you do have to show that you understand your calculus notation, and you can't use this as your justification. Okay? Cool. Let me do the first no calculator one. All right, cool. So I jumped ahead to this one. All right, particle moves along the x-axis, so its velocity is given. Velocity is 0 at 0, 3, and 5. I see that. This is my derivative. Areas are 8, 3, and 2. Since they say the area is 8, you need to know that the accumulation would be negative 8 here. Okay, find the time and position when the particle's furthest left. Time t equals 0, position is negative 2, so p of 0 is negative 2. That's very important to write down. Let's just do all of our work here, and then we'll write our justification. So we have the idea that my derivative is negative until 3, it's positive until 5, it is negative after 5. This is my derivative. That means my position is decreasing, then increasing, then decreasing. And I know the accumulations are negative 8, 3, and negative 2, which tells me how much I increase and decrease. I know my position at time 0 is negative 2. Okay. So here's the problem, guys. If you want to write out your other positions, you have to actually write out all the integrals. So like I know it's negative 2 minus 8, which is negative 10, plus 3, which is negative 7 minus 2, which is blank. So like just a heads up, you have to write this. Now you're doing furthest left. So here's what I would say. That way I don't have to do that much work. A min position occurs when P prime, which equals V, I need to have P prime equals V somewhere. Min P occurs when P prime changes sign from negative to positive or an endpoint, because I have some candidates that I have to check. I know 0 can't be a candidate, but I have to say, I mean, honestly, I could do the following. I could say like my candidates are at 3 and at 6 because P prime is negative from 0 to 3, positive from 3 to 5, and negative from 5 to 6. Like, you could do that. If you say this, no, I'm gonna change it up. I'm changing it up, guys. Min P of t is at t equals 3 or t equals 6, since, and you have to write it down, p prime is negative from 0 to 3, p prime is positive from 3 to 5, p prime is negative from 5 to 6. Cool. Then you compare your two candidates. P of 3 equals, you have to write it down, p of 0 plus the integral from 0 to 3 of p prime, which equals negative 10. And you have to find p of 6. Now you can do whatever you want. I can just say it's p of 0 plus the integral from 0 to 6 under p prime. Or I got negative 2, which is negative 10. And then plus 3 is negative 7, and minus 2 is negative 9. Therefore, p of 3, which equals negative 10, is the min, because I checked my candidates. What is the speed of the particle increasing? You could say V and A have the same signs. You could say when your velocity is going away from 0, or when your velocity is positive increasing and negative decreasing, it's the easiest to just say V and A have the same signs, because if V is positive and A is positive, you're saying that V is positive and increasing. If you have positive values that are increasing, you have values getting further away from 0. If you have V that's negative and A that's negative, this is P double prime, that's P prime is decreasing. If your values are negative and decreasing, you're getting further away from 0. It's very best to just say with speed, V and A have the same signs. Okay. And you can just look at this and just be like, all right, when am I going? My velocity is further away from 0. 0 to 1, 3 to 4, 5 to 6. 0 to 1, 3 to 4, 5 to 6. Okay, part C, when is the acceleration negative? Okay, well, acceleration is the second derivative. The second derivative will be negative when the first derivative is decreasing. So you'll say when V is decreasing. What up, Bennett? Yo, shout out Ben Julian making the homework video. All right, V is decreasing from 0 to 1 and 4 to 6. Average velocity. Cool. I would love to just accumulate my velocities and divide it by my interval. Well, can I accumulate my velocity? Sure, I can. I have the accumulations of my velocity. It's negative 7. So my answer is negative 7, 6. What is the distance? Well, you could say that you're accumulating your absolute values of your velocity. This is just like work that has to be shown. I know you could just get the answer, but just required to do a little bit more. And you got this 8 plus 3 plus 2, which is 13. Cool. Cool. All right. Let's do another calculator, then another no calculator. It's so nice that you could just type it in exactly how you see it. And then just kind of go from there, you know? Okay, the position is -5 at t0. I'm going to start off saying p of 0 is -5. I'm going to say p prime equals v. We're good. Acceleration. Now, this is great. This is p double prime of 3, which is v prime of 3. And like, what's so great about this, guys, is you can do v prime of 3. And literally it gives you that answer. Like it gives you the derivative. Desmos is so awesome. You don't have to do anything crazy. You can say v prime of t when t is 3. Could you even graph the slopes? Nah. That's a little crazy. You can't graph the derivative. I know you can graph the derivative, but not for this one. All right, there's your answer. -2.118. Gosh, it's so great. Trust me, it's so much nicer than using a calculator. The position at time 3. Cool, I can do that. Well, I don't even like need my sign analysis yet. I just know I need to accumulate my velocity, my derivative from 0 to 3. If I want to see the sign analysis, I can see, oh yeah, we have a little bit of decrease. So it's a little bit more intense than you would think. And we got -5 plus -1.760. If I evaluate this, I get 2.84. Yeah. Shout out Sloan Golson. We got our Bennett. Shout out.
Hey guys.
You have to be like right over my shoulder
Right over
because
your
it's
shoulder?
just my head.
Okay.
There you go. You made it. You're
Hey
on
guys,
YouTube.
do your homework. That's my advice.
You're literally like telling that to yourself right now. Okay. So we did it. Okay. Now what is that? That's the change in the position. That's the displacement of position, the change in position over t equals 0 to t equals 3.5. What would that be? It'd be the displacement. I mean, not the displacement, the distance. If I add the absolute value, I'll accumulate all my positive things. Distance. You could also find that by separating it out and looking at, 0 to A to blank, A to blank. So 3.737. Have to distance traveled from 0 to 3.5. Ooh, when does the second particle have the same velocities? Well, the second particle's velocity would be 2t minus 1. So the question is, when does this velocity equal this velocity? And that is at 1.570. What easiness. I mean, like, I'm telling you, Desmos is making all of my homework videos so much faster. What's the average velocity from 0 to 3.5? It's that number that I just found divided by 3.5, which I need to find again. It's like just so quick, so much quicker, so much quicker. 0.812, you probably have to write it down. E You got an integral from 0 to 3.5 of v of t, and you divide it over the interval of 3.5 seconds. Oops. 0.812. This is a truncated answer. If you round your answer, be different. Okay, F. Furthest left, 0 to 3.5. All right. So I'm going to do it my new way. This is my new justification, and I'm jumping on board. We know that P prime is positive until some value A. We have to find that value and then negative. That means my position is increasing, then decreasing. Okay. My only candidates at the beginning or the end. I would say position is a min either at t equals 0 or t equals 3.5. And I say because P prime is positive from 0 to A and P prime is negative from A to 3.5. I got to find what A is. A equals 2.8025. So you got to write that down. 0.8025. Cool. So I know my position at time 0 is -5. I just need to find my position at time A. You need to, not my position at time A, my position at 3.5. My position at 3.5. You could split it up. You could do whatever you want. I'm going to just easily do it by doing position at 0 plus my overall displacement from 0 to 3.5. Many of you need to practice this. So I just need to integrate, accumulate my velocity, and take -5 and add. I mean, I can really see like my displacement is 2.84. I knew that I should have known this answer, right? I should have known this answer because I know my displacement 2.84 means I ended at the end of the day. I'm 2.84 to the right of where I started. Where am I furthest left? Where I started. You could have said that. And if you said that, I would have been very happy with you. Or you could say, here's my winner of my candidates. So again, what did I just say? It's like min's either at 0 or 3.5 because my derivative signs. However, since your accumulation from 0 to 3.5 of your velocity is literally positive, that means you ended to the right of where you started. You could have said P of 0 equals -5 is the min. Like, just because of that. I hope you understand that. If not, you should. Or come ask questions. I'll give you more answers. All right, let's do another no calculator. Oh wow. A B C D E F G. I have to pause the video and come back. This video's gonna be long. All right. Particle 1 has a position. Particle 2 has an acceleration. At t equals 1, are the particles moving towards or away from each other? Well, like, guess what, guys? We gotta do some work. This is literally your test question. It's just gonna be like this, like I promise you. So if you're doing any question to prepare, you're doing this. I'm immediately gonna say that my initial velocity and position are going to give me C. So I'm immediately going to go backwards to P prime of 2 is negative 2t plus 4. It is plus C, but I know that. And P is negative t squared plus 4t plus 8 or minus 8. Okay, because there's going to be a C, but I found C. Cool. All right. Towards or away from each other. I got to know where they are. I got to know how their position's changing. So I got to find the position of particle 1 and the position of particle 2. And then I got to look at the derivative of the position for both of those at that time. So position of particle 1, this is part A, at 1 is a third minus 2 plus 3. So that's a third plus 1, which is 4/3. The change in the position at particle 1 is 1 minus 4 plus 3, which is 0. Okay, well, that's cool. It's not moving, so it's stationary. Now I just got to figure out where 2 is located and how it's moving, and then I'll be able to answer the question. So position of particle 2 is negative 1 plus 4 minus 8. So negative 1 plus 4 is 3. 3 minus 8 is negative 5. Okay, cool. So it's left. Its position is below the position of particle 1. So it's left particle 1. Let's see how the position is changing. Positive 2. That means the position is increasing. So particle 2, if you want to think about it on a position graph, is to the left of particle 1. Particle 2 is to the left, and its position is increasing 2 feet per second at that time. So you would say they're going towards each other. Particle 2 is at the position negative 5. Here's particle 2. Its position's increasing. And particle 1, and this is confusing. You're going to get confused. So I'm just going to leave it like this. So the answer is towards. And you could say based on positions and velocities. You don't have to be more into it than that. Okay. B. What is the displacement of particle 1 and 2 of the interval 0 to 3? Okay, well, is it 1 to 3? Did I really say 1 to 3? All right, good. Well, to find the displacement, let's just find the positions, right? We don't have to like accumulate my derivative. We don't have to accumulate any derivatives because like we already have the position function. So I just have to do this. Here's particle 1. Starts at 0. It gets to 9 minus 18 plus 9. Oh, shoot. It's a 0. Okay, so displacement is 0. And then particle 2 at 0 is at negative 8. Particle 2 at 3 is negative 9 plus 12 minus 8. Okay, so that's good. Something different. So that's 3 minus 8, which is negative 5. Particle 3 is plus 3. Probably need to show your work of how you got that, whether you did P03 minus P2 of 0, or you do I accumulated my velocity from 0 to 3. Part C. Average position of particle 2. I would like to accumulate my position 0 to 3 of particle 2 and divide it by my interval of 3 seconds. However, I don't have a calculator. I have to somehow accumulate the position. How do I accumulate the position? Well, you could think about how the accumulation of P would come from capital P and its displacement from A to B. Take capital P of B minus capital P of A, and you get the accumulation of P. So I need to find capital P. Big fat P. Negative 1/3 T cubed plus 2T squared minus 8T plus C. Great. I need big P of 3. Which is negative 9. I need big P of 0. Oh, that's gross. That's C. Okay, great. I got negative 9. I got C. Negative 9 plus C. And C, that means I have an accumulation of P that is negative 9. And I divide it by 3 and I get negative 3. Yo, since we can check, let's check. If we had a position function that was negative t squared plus 4t minus 8, and I want to accumulate that position function over 3 seconds, and I divide that by 3. I got the wrong answer. Shoot. What happened? 24. Bam. Bam. There it is. There it is. There it is. Negative 5. Negative 15 over 3. There's that negative 5. My displacement is negative 15. Negative 15 divided by 3 is negative 5. Great. I had to use big F. I had to use the antiderivative of position to get the accumulation of position without a calculator. There you go. Oh, D. Find the distance particle 1 traveled from 0 to 3. Oh, jeez. To do a full sign analysis of particle 1's velocity. T squared minus 4t plus 3. Oh, that's not that bad. I hope. Am I going from 0 to 3 or 1 to 3? 0 to 3. All right, so I do have to just work. All right. Negative, positive? No, positive, negative. We do have our position function. What is it? 1/3 t cubed minus 2t squared plus 3t. What was the plus 3? Was the plus 3 at the end? Oh, just plus 3 too. It's literally the antiderivative. All right. So we do have our position function. And P of 0 is 0. Great. P of 1, I need to find. It's 4/3. And P of 3 is -3. You got to understand your displacements. And then you got to make a positive to get positive distances. So I'm going to increase 4/3. And then I'm going to do 3 plus 4/3 as the amount that I decrease. So I go from 4/3 to -3. That's -9/3. 13/3, -13/3. Okay. So if I were to accumulate from 0 to 3, the absolute value of V, I would get positive 4/3 plus 13/3, which is 17/3. I'm going to check this. T squared minus 4t plus t. It's my velocity, just so you understand. Doesn't matter. What did I do? What the hell did I do? 4/3. Oh, it's -4/3. What the hell did I do? Oh my god, I can't do math. My bad. Increase 4/3, I decrease 4/3. 8/3. Thank goodness I checked. Can you guys check? No, so don't rush while you do it. Here we go, 8/3. Money. Cool. All right. E. What is particle 2 furthest to the left? All right. I'm going to erase some stuff. Go back in the video if you want to see. I literally need to erase everything. Like start over. Like my computer's freezing.
Yeah. Oh, thank you. Oh, thank you. Yeah, that's really great. Excuse me. Yes, you tell me. Yeah. Yeah.
All right. So we got particle 2. Particle 2's derivative needs to be analyzed. I can see it's got a 0 at 2. I can see that the derivative is going to be positive until 2, be negative after 2. My position is going to be increasing or decreasing. I could literally say particle 2 is a min either at P of 0 or P of 4, since P prime is negative from 0 to 2, P prime is positive from 2 to 4. So I could say T equals 0, T equals 4. So it's like just referencing your derivatives. You can then talk about what your candidates are. And then you compare your candidates and you win. P of 0 is negative 8. P of 4 is negative 16 plus 16 minus 8. Oh, 2 winners. 2 mins. That won't happen on your test. When do the accelerations equal each other? Oh, well, 2t minus 4 equals negative 2. T equals 1. At what time intervals are the speeds both decreasing? Oh. All right. So we need to look at the signs of V and A on top of each other. So we probably should have had this earlier, but whatever. P prime for particle 1 is positive, negative, positive. I looked at the derivative. So that's my velocity values. P double prime is going to be focusing around 2. That's when my second derivative is equal to 0. And I'll have negatives and positives. When is speed decreasing? When the signs of V and A are going to be the same. So I got 0 to 1, opposite, and 2 to 3. Positive velocities that are decreasing, negative velocities increasing. These are velocities approaching 0. Okay, positive velocities that are decreasing, negative velocities increasing, approaching 0. Let's look at P2. P2 will center around 2. This is the derivative. I'm looking at negative 2t plus 4. Get positives and negatives. Okay, cool. Then P double prime of 2 is just strictly negative. So when are my velocity values getting closer to 0? Positive velocities that are decreasing, so up to 2. So 0 to 1 is the only time that they intersect. All right. To justify, I would say when the signs of V and A are opposed. Okay, great. Now let's pause so I can get lunch, and then I'll try to finish it for chapel. I'm actually gonna. No, I think I can make. I think those will be fun. If this video goes bad, I'm gonna cry. Pause it. All right. This is literally from last year. It was so soft. Like, so soft. This is why 80% of my students passed. Well, it's closer to 90% last year. This is why 100% of my students are going to pass this year. Because you're going to be ready for a free response question like this. Cool. There's my velocity. Oh, gross. Is that really it? Does it have a... Oh. Okay. There's a time between 0 and 2. Did I type this in right? This is gross. The particle's at rest. What is that time? Well, it's when your velocity is 0. It's when your derivative is 0. Here's the time. 0.545. Like, how soft is that? Is your particle moving to the right or to the left? Well, my derivative is positive. So V. I gotta stop. Or I gotta close this off and open it back up. But I'm worried if I do that. So V, yeah, I gotta close this off. All right. What problems do I have to do? We'll find out. So T is 545. V of T is positive from 0 to 0.545. Therefore, particle's position is increasing or particle's moving right. Find the acceleration at the particle. Show the setup. It's V prime of 1.5. That's it. Like, it's gosh, so soft. So soft. This question was so soft last year. V prime of 1.5. Why is this not liking me? Oh, plus 5. Oh, geez. 1.425. All right, there you go. 1.425. Same deal, though. Okay. -1. Is it that easy? Speed increasing or decreasing at 1.5. We got to find 1.5 out there. So maybe we put x equals 1.5. Oh, it's kind of tough to see, but yeah, your velocity is negative. You can zoom in on that. Your velocity is negative and decreasing. You'd say v of 1.5 is negative, speed is increasing. You can either say because the velocity is negative and decreasing, or because v and a have the same sign. You could say that your velocity is getting further away from 0, but that's not really like nice. I don't love that. Okay, it's so soft. What is the position at time 4? Well, like, I know my position at time 1. Let's just find how my position changed by accumulating my velocity from 1 to 4. How soft is this? I feel like they got so much softer. Integral from 1 to 4 of v. And I'm going to add the position, which was -3. -2.802. Show the setup for your calculations. You got to show that stuff. Distance traveled. This, like, I swear, I think I told my students, if any of y'all don't get 8 out of 9 or literally 9 out of 9 on this question, I'm disappointed. But some people forgot about absolute values, or some people thought you had to include the position. I don't care where you're located to figure out how far you travel. 0.958 seems not much. Is that really? Is that really right? Yeah, I guess we're not going down much, or rate of change is not great. All right, cool. Moving on. We did this one. We did this one. Last one. No calculator. Hooray. Oh, fun. This is from 2022. We got particle P and particle Q. Okay, so position of particle P is 6 minus 4 e to the -t. the velocity of particle Q is 1 over t squared. It's moving on the y-axis. Okay, cool. This is moving on the x-axis. P of 1 equals 2. Okay, great. Find the velocity of particle P at time t. So I need to take the derivative. This could be part A. Or the velocity of particle P equals the derivative of 6 minus 4 e to the negative t. So positive 4 e to the negative t is the derivative. Great. B, find the acceleration of particle Q. So that's P double prime of Q, which is the acceleration of particle Q, which is the derivative of this, which is negative 2 t to the negative third. When is the speed decreasing? It's Q. Well, the velocity is positive. Acceleration is negative. So the speed is decreasing. All t greater than 0. Like there's no c's involved. We just have t to the negative second, which is always positive. We got negative 2t cubed for t greater than 0 is always negative. So speed is always decreasing. Interesting. C. Find y of q, the position. Okay, here we go. Position of particle q, which they want to call y of q of t. This is part C, is going to be t to the negative first times negative 1. Add 1, multiply by the reciprocal, plus c. Cool. And I know P of 1 is 2. So I'm going to do my homework. P of 1 is negative 1 over t plus c, which equals 2. So c equals 3. So this answer, yq of t, is negative 1 over t plus 3. As t goes to infinity, which particle will eventually be farther away from the origin? So it's like you guys get intimidated by this stuff, and it's like it's not bad. Particle P is this. As t approaches infinity, you get this idea. Remember the idea of like e to the negative infinity approaches 0? You get, as t approaches infinity, my particle is approaching 6 versus particle Q being negative 1 over t plus 3. As t approaches infinity, you're going to get negative 1 over 30 plus 3. You're going to approach 3. So particle P, particle P will be approaching a position of 6 versus Q, which approaches a position of 3. Cool. Peace. Big video. I hope it saves.